Tensile testing is a destructive testing method that is used to determine the mechanical properties of a given material. This is the standard tensile test specimen or dog bone specimen to be tested. Its dimensions are specified in certain standards such as ASTM E8 and ISO 6892. According to the standards, the gauge length for specimens must be 5.65 times the square root of cross-sectional area, and for cylindrical specimens, this becomes 5 times the diameter of the specimen. This is the universal tensile testing machine that is used for this test. The gray box attached to the setup on the left is a video extensometer that measures specimen elongation by the help of a camera. The grips hold the specimen and pull the specimen at a constant elongation rate. Before starting the experiment, the dimensions of the specimen must be measured by the help of a caliper. The smallest diameter is measured on the specimen and entered to the test equipment software. Afterwards, the diameter is multiplied by 5 to determine the gauge length. Then, the gauge length is measured on the caliper. After adjusting the caliper, the gauge length is marked on the specimen, and white dots will be placed on the specimen as markers for camera to follow. Then, the specimen is placed inside the jaws of the grips of the test machine, and the upper crosshead is adjusted to an adequate height, and the specimen is clamped. The specimen must not slip from the loading axis. Then, the video extensometer interface is used to measure the marker distance that is viewed by the camera. This value is then entered to the software. After all the values are put in and loads and gauges are balanced, the test is started. The elongation rate during the test is 1 mm per minute. The specimen will experience linear elastic deformation until its yield strength, and after yield strength is reached, plastic deformation will start. If the test is stopped after this point, permanent deformation, in this case elongation, will be present on the material. After ultimate tensile strength is reached, a visible deformation in its diameter, known as necking, will be observed on the specimen. From this point on, we can observe the neck very clearly, and the thinning of the neck will continue to occur until fracture. As the load is further applied, the neck will become thinner. The material can't sustain the load anymore and the specimen fractures at the end of the test. Observe that the fracture region is inside the gauge length, which means the test is valid. The stress-strain curve is automatically generated. The specimen is then removed from the test setup and final dimensions are measured for calculation of ductility parameters such as percent elongation and percent reduction in area.